Power transfer theorem states that the maximum power is transferred from source to the load whenever the internal resistance value is equal to the load resistance. So that is the maximum power transfer theorem statement. So let us see. So this is a circuit diagram, Thevenin's equivalent circuit diagram. So here V is nothing but a voltage source, Ri is the internal resistance value, here RL is nothing but a load resistance value. Okay, so here let us consider some current is I is passing into the circuit. Okay, so at that time consider the voltage source V and Ri is the internal resistance, RL is the load resistance. So from that we can define the current passing through the corresponding circuit. Here I is equal to voltage divided by RL plus Ri, because of total resistance in the corresponding circuit is equal to Ri plus RL. So this can be derived from the basic Ohm's law. V is equal to IR equation. Okay, here I is equal to obviously V by R. So from this criteria we can derive the corresponding relation actually. So we know that generally we have two types of formulas. These are for, obviously we have to write down the equation for power. So power P is equal to I square into R. So from this criteria we know that generally I is equal to, this is the formula. If criteria is nothing but we have to prove that one, the maximum power is transferred to the load when the internal resistance value is exactly equal to the load resistance. So that is the criteria actually here. So for that purpose let us consider the assumption the maximum power is transferred to the load whenever the internal resistance value is exactly equal to the load resistance. So for that purpose, first of all we have to consider the equation here. P is equal to V by RL plus Ri into whole square into RL. Actually V is nothing but a voltage source, it is a constant value. Moreover Ri is nothing but a internal resistance that is also a constant value, because these two are a constant value. That means directly we can say that from this power is only depends on the load resistance. So for that purpose, based on that criteria we have to find out the maximum power to the corresponding circuit. So for that purpose differentiate the power equation with respect to the RL value, because of RL is a dependent value, because that means power is depends only on the RL value. So by performing the differentiation operation by using the d by dt of u by v basic formula, okay na. So by doing like this, V is equal to RL plus Ri into whole square, here du is equal to, here I will consider actually, so I think you are all aware of that one. U is equal to RL, so V is equal to Ri plus RL actually. By considering like this, what happens? So du is equal to 1. Okay, if you are taking this is nothing but V. So if you are performing dV is equal to 2 into Ri plus RL actually. So from that we can with the help of a d by dt of u by v formula I will get like this actually. Okay, so when make it to the 0 also. Okay, మనం ఎప్పుడైతే 0 చేసామో then only we can find out the value actually. So when we are making it as a 0, obviously this denominator value, okay, this denominator going to be 0, as well as v is also equal to 0. So obviously we will find only this term means, so this is the value. So obviously here also we will take RL plus Ri as a common factor, then finally we will get RL plus Ri minus 2RL. Okay, so this value is obviously equating to 0. So finally we will get RL plus, so that is Ri plus Ri minus RL actually. Okay, Ri minus RL, so that is equating to 0. Then we will get load resistance value is equal to the source resistance. So that is the main theme actually. So that means the maximum power is transferred from source to the load whenever the load resistance value is exactly equal to the internal resistance. So this is a graphical representation here. So that is nothing but circuit diagram. Here shows that V is equal to voltage source, Ri is the internal resistance, I is the current passing through the circuit, and RL is the load resistance value. So this is actually a graphical representation power versus RL actually. So whenever the load resistance value, so that means RL value is exactly equal to the source resistance, at the time it finds the maximum value, that means the maximum power is transferred here only, that means RL is equal to RI condition only. So here we have to discuss the three important points, that is nothing but the circuit efficiency at a maximum power transfer theorem is only 50%, because of, let us see what is the proof here. So in case of the if you want to find out the efficiency point of view, output power is equal to I square into RL, input power is equal to I square into RL plus RI. I square get cancelled obviously, so we will get here only get cancelled, finally we will get only 1 by 2 is equal to 50%. So that means the efficiency of the maximum power transfer theorem is only 50%. Second thing is nothing but under the conditions of a maximum power transfer theorem, the load voltage is one half of the open circuit voltage at a load terminus. Suppose if you are finding the load voltage is nothing but load current passing through the corresponding load resistance value, therefore from that V is equal to IR, because of by using that criteria here I into RL, therefore I is equal to, we know that V by RL plus RI, by substituting that value whenever we are making RL is equal to RI value, at the time obviously here also same thing, 1 by 2 RL get cancelled, then we will get 1 by 2, that means V by 2 only, that means the load voltage is also equal to total half of the load voltage only. Second thing is nothing but maximum power transfer is equal to V I square by RL formula, by making also we will get V square by 4L, because of RL is equal to 2RL square, RL get cancelled, only we will get 4RL only. Okay, so in case of the practical circuit, if you go for the source is a current, at the time IN is equal to Norton's current and RN is equal to Norton's equivalent resistance. So the applications of the maximum power transfer theorem is in a communication point of view. Okay, so this is a very brief and clear explanation regarding the maximum power transfer theorem. So here very three important criteria is nothing but, so I will explain in Telugu also. Maximum power transfer theorem అనేది ఏం చెప్తుందంటే, maximum power source నుంచి లోడ్ కి ట్రాన్స్ఫర్ చేయాలి అంటే లోడ్ రెసిస్టెన్స్ వాల్యూ అనేది సోర్స్ రెసిస్టెన్స్ కి ఈక్వల్ కావాలి. సో దట్ ఈస్ ద ఫస్ట్ క్రైటీరియా. ఓకే, సెకండ్ థింగ్ ఏమంటున్నారంటే మ్యాక్సిమం పవర్ ట్రాన్స్ఫర్ థియరమ్ కండిషన్లో లోడ్ వోల్టేజ్ అనేది హాఫ్ ఆఫ్ ది ఓపెన్ సర్క్యూట్ వోల్టేజ్కి ఈక్వల్ అవుతుంది. ఓకే, దట్ ఈస్ నథింగ్ బట్ వోల్టేజ్ వెల్ ఈస్ ఆల్సో ఈక్వల్ టు హాఫ్ ఆఫ్ ది టోటల్ వోల్టేజ్ ఆఫ్ ది ఓపెన్ సర్క్యూటెడ్ టెర్మినల్. అండ్ సెకండ్ థింగ్ మ్యాక్సిమం పవర్ ట్రాన్స్ఫర్ థియరమ్కి మన కండిషన్ పాయింట్ అవుతుంది V స్క్వేర్ బై 4L. అప్లికేషన్ పాయింట్ ఆఫ్ వ్యూకి వస్తే కమ్యూనికేషన్ సిస్టమ్లో యూస్. సో దిస్ ఈస్ అ వెరీ జస్ట్ ఏ బ్రీఫ్ ఇంట్రడక్షన్ టు ది ఈచ్ అండ్ ఎవ్రీ average guy also can understand this concept by easily, I think. Okay, thank you for watching this video. Please subscribe if you are not subscribing, and please share your friends also. Okay, thank you for watching all of you, man.